Now, I would like to welcome our speaker for today, James. James is basically a blockchain developer, researcher, and investor in the crypto space. James has been exploring and experimenting with blockchain technology and is fascinated by the ability to deploy permissionless, immutable code across a decentralized P2P network. Today, James is an active member of crypto community, talking at events and contributing to open source code. His YouTube channel has grown to 13,000 plus subscribers, and his website receives 100,000 plus unique visitors a day. Welcome, James. Thank you for joining us today.
Hi, thank you very much for having me. Okay, so what we're going to be doing today is talking a little bit about Solidity, and we're going to develop some smart contracts using some common token standards. We're going to be using an ERC20 token and an ERC721 token. And then we're going to deploy that to a Ethereum testnet and then write a decentralized application to interact with that smart contract. I'm going to share my screen now and we'll get started. Can everyone see the screen? Assume we can.
Yes, we can.
Okay, so this is what we're going to be trying to build today, or we're going to be putting together. And it's a simple decentralized application where we can connect our wallet, mint an NFT. That's going to take a couple of seconds to go through just because we're actually working on a live testnet here. A testnet is similar to the real Ethereum mainnet. It's just kind of the tokens have no real value. So we're using like pretend ETH to pay for the transaction fees and things like that. We can then, the reason I'm doing this particular NFT is because it's dynamic. And what I want to do is combine two different types of tokens, non-fungible tokens, which most people will be familiar with, and fungible tokens. A fungible token is what we're doing now. We're going to earn some of these. And if you imagine something like Ethereum's native token or Bitcoin, one token is exactly the same value as another token. One Bitcoin is always the same value as another Bitcoin. There's nothing really there, which kind of, there's no difference between the two. So once we've got some tokens in there, we can then use them tokens to upgrade our NFT. So this is an NFT and it changes, and we can upgrade that because we have this balance of the fungible tokens. And what we're doing is upgrading this to an alien. And once that goes through, and the way this works is we've basically got two images here. I've got a little bit of help from OpenAI's DALL-E image generator to create this. And it depends on if that token is graded, then it shows the second picture here of the alien NFT. So the first thing I want to do, have a look at code. This is all open source on GitHub. The contracts and the front end work are all here. And that's James Bachini /women who code. And then if we jump in, so this is an IDE. It's a kind of a code editor for Solidity, which is the programming language of Ethereum. And we can use this to kind of build smart contracts. So it's really useful just for kind of experimenting. So if you go to remix.ethereum.org, we can put together, we can just kind of create our first contract here. So let's create a new file. I'm going to call this womenwhocode.sol. .sol is, or .sol is the file extension for Solidity files. And then we're going to want to add some code here. We can copy the files. We've got an S identifier and the version of Solidity, the first two lines. We're also going to want to use a library. We're not going to code this from scratch. We're going to import a library. And one of the best places to import libraries for Solidity code is a project. If we go to OpenZeppelin's website, we can see we've got this wizard. And this is actually, I found this, done it, but this is actually very similar to the initial token I want to generate. So we're going to start two tokens in this contract. One is going to be an ERC20 token. Then we're also going to have an ERC721 token, which is the non-fungible token, or the NFT. The ERC20 is a little bit simpler, so we'll start with that. And we can see this wizard kind of gives us this basic, the MIT license, and then the version of Solidity that we're using. Then we're importing the library from OpenZeppelin. We've got a contract here and a constructor argument with the name of the token, and that's it. We also So we want to actually mint some tokens when we deploy a contract. So whoever deploys a contract ends up with all the tokens. And if we copy that, and remix, Control-C to copy, Control-V to paste, we can then compile it, we haven't got any errors. And we'll start by deploying that locally. And you can see we've got a version of a token here. If we copy off our address and paste that in here, we can see we have the entire balance. This is a really bigger number because it's bigger than this because we've also got the decimal places included. There's a couple of bits that I want to actually change here. I'm going to copy the original out. So one of the things I'm going to do is change this to version 17, the latest version of Solidity. And I just want to change the name of the token. So I've got the women who code, and then the tick symbol, which is just like an alphanumeric symbol for the token, which will be used for things like CoinMarketCap and things like that. And at the start, we're minting 1 million tokens. Try saving that. Got the version of Solidity here at 0.8.17, which matches the version here. And that compiles fine with no errors. Again, or we can actually deploy that. If we go to injected MetaMask provider, we can deploy that to a testnet or even the Ethereum mainnet if we wanted to. And that is a very standard token. You might have seen like the Uni token, or it's a standard ERC20 token that people use for a lot of things within the Ethereum ecosystem. The next contract I want to go through is a little bit more complicated. I want to and then go through all the different functions. So this is our NFT. So we've got the contract name is Women Who Code, and it's an ERC721 contract. We're actually going to have to put a couple more libraries as well. Up the top here, we have to import the ERC721 contract library, and you can see a very basic version of this here. So if you wanted just to create a basic NFT, this is what it would look like. It's very similar to the ERC20 token. It's just a different standard. Then we've got some additional functionality as well. So we've got some state variables at the top. We've got a token address, which is actually going to be this token, the address of that. And then we've got a token ID, which is every NFT has, because it's a unique individual item, it has an ID or a reference number. And then we've got is alien, which is just true or false. Is this NFT been converted to an alien yet? Okay, so now we come to the constructor argument. And again, we're passing in a name and a ticker symbol for the NFT itself or the collection of NFTs. And we're actually going to deploy this contract from within this constructor argument. So this contract is actually going to become the owner of all the tokens. So because this contract is deploying that, the message.sender gets converted to this contract as it's being deployed. That deploys the ERC20 token, which means that all of these tokens, as they get minted, go to message.sender and held within this contract. So the only existence of this ERC20 token is held within the NFT contract itself. We then need a way to get them out. And here I've created a very simple earn tokens public function. So this is something that people can call externally from MetaMask, and linking this up to the decentralized application later. And the earn tokens function simply uses the ERC20 library and a token address, which is set in the constructor as well to this state variable. And it's transferring out to the person that calls the function 100 tokens. So that's the ERC20. That's the way you can kind of get the ERC20 tokens out. But to mint an NFT itself, which is what this contract's kind of be used for, we need a mint as well. Now, we've limited this to a total supply of 1,000 tokens. So there's a total of 1,000 that can never be minted. And we're going to use the safe mint function, which is an internal function for that Open Zeppelin library. Again, they have a lot of documentation on the different functions you can use within the library contracts here. and you'll find all that information on OpenZeppelin's website. A lot of what, when you're developing on Solidity and for Ethereum, a lot of what you're doing is interacting with these different tokens, and being kind of familiar with ERC20 and ERC721 particularly is really useful. So you know what functions you're going to be working with and how to do certain things with them and getting comfortable with that. And finally, we increase the token ID reference. So this is this variable here, unsigned integer, and we're just adding 1 to it. So every time that someone mints a token, it adds 1 to that, and the next person gets the next token ID. The next public function that we got here is a make alien function. And what we want to do here is make sure that someone has this balance. So the idea is that people need to collect these tokens, and maybe there would be some kind of system where we have more logic in this function to make it harder for them to earn tokens. They might have to complete certain steps in a game or do something on social media, share a post to kind of earn these rewards. And that enables them to earn NFT and alien NFT. And all that's doing is changing this true or false Boolean variable up here. So first of all, we want to check the balance of the user. So we check that the ERC20, the interface for the ERC20 token is how many of them tokens that user has, message.sender, the person that calls this function. We then require that balance is over 100. So we get 100 every time we call this, and we just want to check that they've got at least that amount in their wallet. Again, we could add more functionality here if we want to take this a step further and kind of burn them tokens or kind of have them spend them tokens rather than just kind of checking they exist. But for now, in this kind of simplicity stake, we can use that system just to kind of check they have a balance. And then we also want to add a require statement here to check that the owner of this token ID is message.sender. So you can't convert someone else's NFT. And then finally, we just simply that is alien for this token ID to true. The final step in creating a dynamic NFT, so what we want to do is kind of display different data depending on whether it's an alien or not, is to take the token ID, and this is the token URI, which is a public function, so we're actually overriding this. So this is a function from the library. We're putting our own version on top of that to add some extra logic. We've got some JSON data here, which provides a name, a description, and the start of an image file. So we're using Cloudflare's IPFS here, and we're uploading images using nft.storage, which you can just kind of drop and drag images into, and that'll give you an IPFS address. So it's quite an easy way for you to host remote images on a pseudo decentralized network. Then if the alien variable is false, we send one avatar, we send one hash here, which sends them to the avatar.ping. This will be, that's the wrong one, but we've basically got 2 files here. One is a standard image and the other one is an alien. So if alien is true, send them to the other image, and then we're going to combine them 2 JSON strings together. So we're basically going to put this JSON string on the end of this one, and then we're going to encode that and send it back as a base64 string. So we are returning a string here, and if we deploy this contract, let's save this. Let that compile. And we can deploy it locally to start with, just to test it out. Come down here and select women who code. If you want to deploy this contract, not just this one, and this one in turn will deploy this one for us with this line here. So let's deploy that. And we can check the address, which is the token address for this one. And that will provide the tokens for this. So the first thing we need to do is mint an NFT. Let's do that. And then if we check the owner of NFT 0 is us, you can see that address should match this address up here. Then we can, once we've minted our NFT, we can earn some tokens by calling earn tokens. Where are we here? And now we should be able to convert our put token 0 in here, make an alien. You see that transaction has gone through. So if we get the token URI for this, because this is JSON data, we can actually paste this into a browser. So we can paste this in. You see what this is what's being returned. And if we take this image here, it should show up an alien. And there we go. So these NFTs are compatible with OpenSea and other third-party sellers as well. So this is our basic contract. Now, what we want to do now is, because we're like deploying this locally within the browser, we actually want to deploy this on a testnet so that we can interact with it from an application. So let's close this off. And we want to change this to injected provider MetaMask. We've got MetaMask loaded up here. And we've also got some Goerli ETH in our wallet. So Goerli ETH is just like testnet ETH. It's free. If you kind of Google testnet faucet or Goerli testnet faucet, then you can kind of get a free amount of that distributed to you. And you need, in MetaMask, you need to change, like show and hide test networks, and then come down and select the Goerli test network. So once we've done that, we can deploy the contract. We have to pay a gas fee for this. It's going to take a few seconds to go through. And it's actually deploying two contracts here. So we're going to have one contract address for this contract, the ERC721 NFT, and a second contract address for this token, which is the ERC20 fungible token. And this is the contract address for the NFT. And then this is the token address for the ERC20. So we can also mint our first NFT here. And we can interact with this contract in the same way that we did when it was locally hosted. We just need to sign transactions from within MetaMask. And this would be exactly the same if you're doing it on Ethereum mainnet as well. You can deploy code to the Ethereum mainnet if you want kind of NFTs and contracts on live on Ethereum. So next step we want to do is create a decentralized application for this. So we can actually do a second version of this. I'm going to create a new folder, WWC2, and I'm going to open it in terminal. And first I'm going to do npm init to initialize a library. I'm assuming you've got Node.js installed, so you're going to need that to run it code. And we're going to hit enter on all of this. And then we install npm install -save create React app. So we're going to be using React, which is a JavaScript framework for building kind of sites like that. And we're going to install Ethers, which is a Web3 library, and this connects the front end via MetaMask to an RPC node or a node on the Ethereum network, or in this case, the Goerli test network. Okay, now we can go ahead and create a new project. So npx create React app, and we'll call it WWC. That's going to take a minute. While that's installing React, what I want to do is go and grab the APIs for this. So let's over here. If we go back to the compile page, it's on here. No, it's on deploy. Somewhere we can definitely grab an API. Here we go. So we've got the token API here. So this is the ERC20 API, and it's just at the bottom here on the compile tab. You've got a little button, tiny button, which says API. We can copy that, open up a text editor. In this case, I'm using VS Code, and we can paste that in. And the API is like an instruction set for working with smart contracts. Basically, it basically tells the JavaScript library how to interact with the smart contract. So let's save this as code, WWC2, source, We'll call this one ERC20 ABI.json. And then go back and select the women who code contract, which is this one. We can copy that, paste that in, and save that as ERC721 ABI.json. Let's see if React has finished. It has. So let's now move into that library. And you can see we've got a directory structure here. And then we can run the command npm start dev. Oh, we have to close one down first. And what we should get is a blank React app. So we've got a standard, very simple React application here. So now if we go to WWC and go to source, most of the code that we're going to be using is in app.js. And I am going to copy and paste from the previous one and then go through it, I think. Save time. Okay, so the first thing I'm going to do is import the React application, and then I'm importing some CSS. And then I'm going to import these two libraries. Actually, call something else in this one. So ERC20 ABI and ERC721 ABI.json. We're then importing the Ethers library, which is the JavaScript framework, which we use to connect to the node. And this has got a really good website as well, which I'm going to show you. There's JS docs. So when you're using this, it's always a good idea to just kind of go through the different ways that you can kind of, the things you can do with it just to get an idea. Like if you wanted to know the block number, for example, you can use, or you want to download the difficulty for a block, you can use this command. And just going through the documentation really helps, especially if you're going to be using something like this a lot and building decentralized applications in the future. So we're then setting some state variables for provider, signer, address, token NFT, and token ID. And then we get into our main app. So we're using state for a message here, and this will be the message. Just move this 1 sec. So this will be the message that comes along the bottom. And then we've got two addresses. So I'm going to update this to the new addresses, which we just printed. So we need the token address first. If we go back to Remix, we can get this from the deployed contract, just token address. Let's copy and paste this in. And then we want the NFT contract as address as well. And that's just this one here. So you can see at the top, women who code. Let's copy that and paste that in as well. So we've got our two most recently deployed contracts. And then we've got some functions here before we get into the HTML returning the application itself. So if we look at the HTML first, we've got a quite simply, I'm just going to zoom in on this so everyone can see it. We have a headings, a couple of headings, H1 and H2 are just HTML tags to define headings. Then got an image, which is or a div container for an image, which was where the image will go eventually once it's been minted. And then we've got a container for some buttons. And on click, we set these to the functions above. And finally, we've got that state variable for the message, just kind of give update information about what's going on while we're actually interacting with the decentralized application. So the first function below the contract is the connect. And whenever you kind of launch an app, you need to connect a wallet to it. So the most common wallet is MetaMask. Really great. If you've got a copy of it, I definitely recommend downloading it, plug it for Chrome and other browsers, and you can connect that. So it's already connected, but normally it would give you a notification to say, like, do you want to connect to this site? And then once you've done that, you can get the address, and it gives you permission to sign transactions and things like that. Or you sort of pop up a notification to sign transactions. Once we've defined the provider, which is connecting MetaMask with this, we're going to get a signer, which kind of allows us to actually send transactions. So there's two different types of transactions in Ethereum. One of them is to read data, and that's a free transaction, and anyone can do that. You don't need to pay a fee. You can read data off the blockchain at no cost. Whenever you modify data, or you change data, or you upload new data to the blockchain, or to state variables held within the EVM, you need to pay a transaction fee for that. You are charged to modify data and upload new contract, change a balance, kind of anything you want to do on chain which kind of changes the state. You pay a transaction fee, and someone needs to sign that transaction from within MetaMask. So we have this signer value here. Because we're going to be doing signer transactions, we need to kind of pass that through to the token and the NFT itself. So the token is the ERC20 and the NFT is the ERC721 contract, or the Women Who Code NFT. And we're going to create instances of both of these because we're going to want to interact with them. And because we've got them as state variables here, we can interact with them throughout the code. And then finally, we're going to get the address, which is the user's address. So when you set up a MetaMask wallet, you're going to get a private key and then a kind of a public address. Your private key or your seed phrase is secret. You should never give that to anyone. There's never any reason that anyone should ever ask you for that. But the public key address, which is, or the address which is derived from the public key, is this one here. And that's fine. Like if you want someone to send you ETH or send you tokens, you can give them that address. So that's what's coming up. You can see it's 0x123, and that's the same here. We're kind of getting that from within the JavaScript code. So all we're doing then is send a message, say you're connected, and everything's fine. Then we've got the mint function, which we need to actually sign a transaction here. So the transaction await, we're using async await here because we need to wait for the blockchain to execute, and nft.mint, and that .mint function is passed through from the ABI to from the smart contract. If you look at the smart contract again, you can see we've just got this public mint function here, which is exactly the same. So all we're doing is calling the NFT contract with .mint function right here, and that's going to execute that code on the remote network. So we're calling that, while we're waiting for that, we get this await tx.wait, which just waits for it to confirm on the blockchain, because we need to wait for that to do the next process. And we're just going to do processing transaction. So it's just changing the message basically. Once that's gone through, we can get the token ID for the contract. Because the token ID is the value, the current or the next value to be minted, we actually need to take one away from that. So the token ID -1 is the NFT that we've just minted. And then we're going to encode that in a similar way to how we encoded we're going to receive the encoded data. So we're going to call nft.token URI, and that's going to call this function here. We're passing through that token ID to get the JSON data that we looked at earlier. That's base64 encoded, so we need to decode that to JSON and then take the image URL from that. So we've got the .image variable at the end once we pass the JSON and decode it from base64. Once all that's done, we can send a message out saying you own the Women Who Code NFT number token ID, and pass that token ID. And we can actually insert that image URL into the front end. So that's how the image is popping up when we do this. So once we've minted the NFT, that will automatically go through. It will load this. We wait for it to go through, and then we actually load the URL from that image, which loads the image data itself from that IPFS address, which we looked at. The next function is the next button, which is earn. Where are we gone? So we've got this earn function. This isn't very well done yet. I think I need to update the CSS as well. But we've got the earn function here, which is just calling the NFT contract again, and we're going to call .earn tokens. Now, if we go back to the NFT code, the Solidity smart contract code, again, all we're calling this public function. It's actually, because we're transferring funds, we're changing the data on state. So again, that's a transaction that we need to sign with MetaMask. Below that, we have an example of a transaction which we don't need to sign anything for. So once the transaction has gone through, we're waiting for the transaction to go through and be confirmed. And then we can check balance of. So we can check balance of this address. And because we're only reading the data then, we don't need to, we can do this. It takes a little while. It's not like blockchains aren't built for speed, but within a couple of seconds, we'll get a balance back and we can update with that saying your balance is now balance from set message. So this function here is actually part of the token contract, and you won't see that in the remix file because it's actually part of the library. So where we have the contract here, there's no public functions here because we're literally importing them from this library, and that's doing all the hard work for us. If we ever want to kind of find that, we can just type in ERC20 GitHub, and the first one will copy the Open Zeppelin contract. And here you can see all the different functions. So one of them will be balance of, and we can see that that takes an address. So you pass an address and you get a number out. And you can see that's what we're doing here. We're passing an address and we're taking a balance out, and we're just displaying that in the variable here. The final function that we want to do is create an alien NFT. So we're going to call this alien function from a button again. The button is here. On click, it calls the alien function, which is defined with the curly brackets. And the alien function calls the make alien using the token ID that we generated. Because we called that in the mint function, we know that's our own, so we know we're allowed to do it. That sets the message to something strange is happening. We wait for that transaction to confirm. And then again, we're taking the data in the same way we took it from the original image. We're decoding it, and then we're displaying the new image, and it says you own new code alien NFT, and the image URL should update to an alien. So the last thing I'm going to do is update the CSS for this because it was a little bit ugly about it. So let's copy that in. The CSS is simply styling code. It makes it look pretty, basically. You can see we've got some custom code here for the image and image container, the title tags, and the buttons itself. And I think there's a little bit up here as well, just for the background, change the background color and to import a custom font for that library. If we save that now, we can open this up and you can see there's no errors. And it looks a lot more pretty. Let's refresh this page. Connect our wallet, we can get our wallet address. If we go ahead and mint the token, we should be minting token number 1, I believe, or token number 2. One thing to bear in mind with arrays and things like that, it often starts at 0. And if you have a variable in Solidity which you don't define, like this token ID, that's automatically defined as 0. So let's just wait for that to go through. We've got our NFT. Now we want to earn some ERC20 tokens to pay for the upgrade to an alien. So let's go ahead and earn some ERC20 tokens. And one thing we can do here is we can actually add the token contract address to MetaMask. We could do this with a button, or we can actually go in and copy this address here. We could display this on the website as well. And go to assets, import tokens, paste the contract address in here. You see our token symbol, token decimals, and our balance is currently 0. Once that transaction is confirmed, contract interaction should be updated. It might be showing because I'm not using decimal places here, so it's just showing a really tiny number. So we've actually got 100 tokens, which is like 100 Satoshis. It's a very small amount because we've got 18 decimals on the contract itself. We can use them now to mint an alien though. So let's go ahead and mint an alien. And we've upgraded that NFT. So by calling this function, we're converting this variable here, which is alien, which is using this mapping so that every token ID has a true or false to it. And then we're checking that here, and we're sending out a different set of JSON data depending on if it's an alien or if it's not. Again, you could take this further. You could actually kind of create 10,000 different images and kind of add the logic there to pass through the token ID. So the JSON data includes the kind of number 1, 2, 3, 4, 5, 6, 7, etc. And that could kind of relate to image 1.ping or image 2.ping and kind of things like that. You can see we've converted the Women Who Code dynamic NFT to the alien. Is there any questions? Let me just open this up. Kind of whizzed through that a lot faster than I was expecting. Does anyone have any questions or anything that I went too fast through?
Are we through?
Yeah, pretty much.
Okay,
that was a lot quicker than I was expecting.
Sure.
I feel like I rushed.
No, I was attending it. It sounded fine. It was fine. Let's see if we have any questions from our attendees. In case you have any questions, you can either drop them in the chat window or in the Q&A section available in the below panel. Okay, seems like we don't have any questions as such. All of you can join our Slack channel for any follow-up questions that you might have. The recording for the session will be available on our YouTube channel, the link for which has already been shared in the chat window. Feel free to check us out and join us for our next session on Build. We'll update the information about it on the Slack channel again. Thank you, everyone. Thank you for attending today. Thank you, James, for hosting this amazing session. Thank you.